keys and rooms, and you can do it both BFS and DFS ways, but let's just look at the difference between those two first. So when should we use BFS or DFS? So for BFS, we use a queue to record which rooms we want to visit in the future. So by default, we're gonna queue.offer something, right? So like the starting position would be like index 0, and then that index 0 would have certain values like 3, 5, something, and we pull those values inside the queue to be visited in the future. And we can use a unordered set or hash set in Java to record the places that we have visited. This is really important, or else it will go in an infinite loop so that we don't have to visit them anymore. So push the starting point to the queue and use a while queue is not empty. That's the ending condition, and blah blah blah. Okay, but BFS, I don't know if they said it here, but basically BFS, I personally think that it's harder to implement than DFS, and BFS is usually meant for finding the shortest something, like the shortest path to something. But DFS, depth first search, is that we recursively call itself with changing parameters. So once we place that starting position, like for example 0, it will recursively, from this 0, it will go very deep. Hence its depth first search. What do you mean by very deep? So BFS, unlike BFS, so it's saying that if certain conditions are met, so if we have not visited this node before, and if this node doesn't go beyond the boundary of the grid or doesn't meet certain criteria, then we can do this DFS. And yeah, like go left, go right, go down. So unlike BFS, DFS is going one direction straight very deeply, and if that path is unavailable, then we recursively call back and come back to the starting position and try another way. So we come back to the previous recursive call and try another way. So that was the difference, but let's see. So this one doesn't really require the shortest path, right? We just want to see if we can visit this room or not by getting this key. So for this, I'll use a DFS because that's my personal preference. You can use both. You can use whatever you like. But first, always for BFS and DFS, you have to create some kind of way to mark the visited node or room as visited. So you can use a hash set or unordered set in C++, or you can use a Boolean array. So I'm going to use a Boolean array here. So new Boolean of rooms.size. Okay, so in Java it's defaulted to false, right? So I will do a DFS call with parameters rooms and visited, and the starting position will be 0. So it's same with BFS. You have to give a starting position. So for this, I'm gonna give 0. And the basic logic for here would be that if we have not visited this node or this room or any room actually, then we're going to return false, because that means that we didn't have a clear path to visit this room. That means we didn't get the key, right? So that would be false. And if we have visited all rooms, then our visited Boolean array will contain all true values. So that means we can return true. So if boolean visit, if the values in visited, oh no, sorry, 4. If even after recursively doing, even after doing a DFS search, we still encounter a false visit, that means that we didn't visit this room, so we return false. And if this all passes, then we return, return true. Okay, so I'm gonna create the DFS now. Rooms and visited, boolean visited, and we're gonna give a starting position, right, of A, but it will be recursively, the parameter will be recursively changed, right? Here it says with changing parameters. So always we have to mark the current node as visited. So visited A would be true now. Previously it was false, now it's true because we have visited this starting position. And so what we do is we do rooms is a list, has a list inside a list. So we know that rooms.getA would give us the values inside this list. So for example, this one, like if the starting position is 0, then the first recursive call, when we do rooms.get0, it will give us this list of 1 and 3. So for int A, A is used, so let's say I in rooms.getA, and if we have not visited this node, this room, then we continue the recursive DFS call, and we pass rooms visited I. Okay, and yeah, that's basically DFS. Run. Okay, submit. Okay, just one short notice, note is that, okay, so once we get the integers like 1 and 3, if we have not visited this node, then we do the DFS search, right? So although we start from 0, the starting position is 0, right? So 1 DFS of 1 and 3 will be done, and this will branch out to all the possible rooms or nodes, I should say. And if our DFS search doesn't mark all the nodes as true, then we return false, because we have at least one room that we know we could not have visited that node or room, so we return false. Okay, that's it, and I'll see you guys next time. Bye.